Okay, so hello friends, welcome to BISP Solutions. BISP Solutions is a tech company, provide technological solutions across the world. Now in this our today's bootcamp session, we are going to discuss on vendor risk management, assessment, vendor risk assessment using artificial neural network. Now what is this vendor risk assessment? Let me give you one scenario first, one daily life scenario, then we will relate that scenario with this today's topic. And why this NetSuite icon is appearing here? Because we are working on the data which is extracted from the NetSuite ERP, right? So that is why. So we are connecting machine learning concepts with business concepts. Okay, so let me give you one daily life example. Like for example, while making friends, we assess the person on different criteria. For example, I have 4 friends, right? One friend always comes to me, and whenever I call him for any type of help, right? This is one type of friend. Another friend who never comes on time, but he always supports me financially. Whenever I ask him for some fund, he helps me. Third category, I have one more friend whose father-in-law or whose relatives are on higher post in government. So all these 3 friends are useful for me, but bases are different criteria. On the basis of different criteria, these all 3 friends are useful for me and they are very important for me, right? So while making friends or while making partners, we can say, instead of friends, while making partners or connecting or to prepare to increase the connectivity, we assess the person on different criteria. Same thing is here in business scenario. We are making so many vendors, right? Suppose in a business there is a builder, construction builder. Now he is having so many vendors, but there are different kinds of vendors. One vendor who gives the material on time, but very small amount. Second vendor who follows the RERA compliance, or we can say some government compliance, but he gives you the material on not on time, a little delayed, because due to all government procedures. Third vendor, he always gives you huge amount of material, but he rarely follows the government compliance, and the material is of substandard material. So there are different vendors required in a construction business, and based on different criteria, there is a risk also. For example, the vendor who gives you immediate material, but there is a risk whether he has followed all the rules and regulations, all the compliances. Second type of vendor. So these are called the level of risk while working with third party. A vendor is a third party. He provides you the material, he supplies you the material, right? The builder who look after the projects and who builds the building, but the vendor who supplies the material, they are the third party, they provide you. So based on different risk criteria, there is always a risk assessment should be there, that how much risk will be there in working with this type of vendor, how much risk is there in working of that type of vendor. So these things are also done by the builders, but in common people, they never know all these things, right? So this is how we are going to now discuss that what is vendor risk assessment. Now the criteria, the scenario is clear to you, right? What is the types of risk, and we have to assess that risk. Now see here, vendor risk management is the process of identifying, assessing and mitigating the risk associated with engaging third party vendor or suppliers who provides goods or services to an organization. That is what I am talking about. That means it is the process of assessing that what type of risk is involved while working with this vendor and that vendor. Now there are different types of things that we need to see. Information monitoring, we have to monitor the information also, what type of information is being given, what type of information is being circulated. Multi-system integration. Multi-system integration means, for example, you are working with another third party, because in a building construction, the one vendor who provides you cement, one vendor who provides you the steel material which is used for construction, one vendor will provide you the marbles. So all these things are integrated. Enhanced visibility, you have to give the visibility also. Then preferred vendor list, you have to first select the what are the preferred vendor list. So these are all the things which are done by the businessman, right? And ordinary people, they don't know all these things. What is a vendor risk assessment process? Now see, selection. Initially screening to shortlist vendor with low risk levels. Now see, because nowadays there are so many rules and regulations, so we have to first select the vendors list first. Then onboarding, vetting vendors controls before allowing access. Yes, first you have to put the vendor controls before allowing access to your business. Third is monitoring, regularly checking performance contracts and compliances. See, monitoring means, suppose today government has declared one another rule, tomorrow government has passed any other rule, so you have to monitor the activities of government also. Fourth is termination, securing data protection when relationships ends. For example, a builder has decided not to work with this particular vendor, so at that time you have to secure the data protection also, because when a vendor gives you the goods and the materials, definitely he also has some information related to the building. For example, let's take an example. I am constructing a building, right? Now for whom I am constructing a building, that I don't need to disclose. For example, while ordering the cement, if I order the best quality cement, right, or very low quality cement, so for what purpose that building is being constructed, that should not be disclosed. That is called data protection, because if I disclose that I am constructing this building for business, government purpose, government building, right, government department, in that case that information can be spread by that vendor, and the vendor also knows that what is the structure of that building, right? So this is called data protection. For what purpose that building is being used, or the internal map or the internal architectural documents, they should not be disclosed. That is called data security. Incident response. Now determining breach impacts and developing mitigation plans. Same thing, incident response, determining breach, what type of data breach or what type of security breach is done. For example, I am a builder and I am building constructing a building for school purpose. Now suppose that type if the internal architecture of that building is leaked or is given to some other people, that should not happen, because in future if the internal structure, internal map is given to that any wrong people, so it might create problem in future, right? That is why you might have heard that whenever a building is hijacked, or the hostages are kept in that building, army and military, they first check the internal architecture of that building from where they can enter securely. So this type of, because that is why always whatever the building is constructed, the internal architectural design is never shared with anyone. Okay, so now the idea is clear to you that exactly what we are doing and why we are doing today. The vendor assessment, vendor risk assessment, what type of risk is involved while working with vendors, what information should be given to the vendors, what information should not be given to the vendors, why we are purchasing that material from that vendor, because a vendor can provide you different category material: standard material steel, standard steel, substandard steel, very low quality steel, right? And suppose if the information is leaked that you are constructing that building for a school purpose, then he might misuse that information. So all these things that are assessed, but how you will assess that which vendor is correct? Based on his past performance, that's it. For example, if a child, he obtains 90% since childhood, LKG, UKG, first standard, second standard, up to 12th, so definitely you can think of giving him scholarship to study the medical science course, right? Because based on his past history, you can take a risk that okay, we can spend money on his medical education, right? So this is called risk assessment. What type of risk will be there or will not be there while working with that particular person? That's it. Now let's come to the practical part. First of all, I have created one CSV file. See what happened in an ERP. ERP can be used by any company, like whether it is a furniture selling company, whether it's a construction company. ERP product, NetSuite is an ERP product, and it can be used by any. So one vendor is using this ERP, and we generated a report of all the vendors, their details, right? And what type of details we have accessed from that report, that I will show you soon. First of all, let's create a new file interactive Python notebook. Now let's see this. First of all, what we need to do, see, we are working on IT, right? So first of all, we need to pull all the necessary libraries. These are the libraries which will be used because we are working on machine learning concepts, right? So machine learning learns the historical data with the help of some tools. So those tools are imported. The Pandas library is a very well known and famous library. Torch is a module, and inside that neural network is the function which is used. Optimization, train, test, split, standard scalar, etc. All this pyplot, PLT for plotting the data, right? So we need to first import all the libraries. After that, what we need to do, we need to import that Excel sheet also, that CSV file. Okay, so all the libraries are imported. Okay, now we are going to read this. Now see here, total 1000 rows, financial health. Now see what is the financial health of that vendor. We have eliminated, we have removed all the vendor IDs. First, we have not used a vendor name and IDs. Compliance scores. Compliance scores means compliance means the rules which are set by the government. In India, there is the RERA compliances. If you talk about India, there is a RERA compliances which is to be followed by all the builders. Okay. Now, here compliance score, how much a vendor can, how much a vendor follows the RERA compliances or the compliances, government compliances. Past incidents is also given the score here, right? Past incidents means, for example, many times the vendor face the police cases also. So past incidents, based on these past incidents, what happens many times, the pools collapse. So all these things are called past incidents. And the delivery reliability, how a vendor delivers you, in how much time a vendor delivers you the material. And the final is risk score. This is the risk score. For example, if you see here, this vendor has 6 incidences past. Compliance score 43. Point 43 means he follows the rules 50% only, not all the rules he follows. Financial health 56, that means it's a big risk. 0.83 means it's a big risk, and 0.45 means 50% risk, very low risk. Now see here, past incidents happens only 2. Now what type of incidents, that we don't know, but it is counted, right? Then 68 is the compliance score, that means he follows maximum government rules, and financial health is very good, so risk is also very less. Okay, so this is how it is calculated. Now we are having the table, and let's check it out. Okay, now see here. Now see, target is risk score, feature means whatever, actually it is the same as independent variable and dependent variable. Independent variables are those which are already existing, that means features means they are called features. Features means financial health, compliance score is past incidents, delivery reliability, and risk score is taken into the target, that means that is what we are going to extract, right? We are going to calculate. Now what's next? Here you see the split data, and first of all we need to split the data into both. Now see, x equal to df features values, y equal to df target values reshape. Reshape means, see, reshape means whenever we work, we distribute the data into -1 to 1, so that it will be easy to work with, right? For example, if let me show you. Now look at this risk management. Okay, this data is divided into -1 to 1. Already it is between -1 to 1, right? So normally what happens, suppose for example in a school or in a 12% or metric student, whatever the books are available given by government, but for exam purpose we create our own notes which are elaborated, right? So we use those notes, not direct that book. We read the books, we prepare our notes in a good form, in an elaborated manner, and then that answers we write in the exams. Same thing is here, we convert them into, reshape into -1 to 1, and then machine will learn it, machine will work on it, and then we reverse transform it. Okay, now see here. Now again normalize feature. Now see here, x, look at this, we have normalized the data. As just now I have given you one example, that whatever the books from the shop we buy, directly we don't write the same language which is written in the book in the same exam. We just prepare our notes, and then that notes are written in the paper. Same thing is here, scalar dot fit transform x, this complete data is converted into -1 to 1. Okay, after that let's check out here what next. Train test split. Now see here, train test split. Here we have taken the train test split function, right? Now this train test split function means it divides the data into two parts, 80% in training and 20% for testing. Training means whatever the 80% data it is using, that is for training itself. That means it creates a pattern, and testing for that particular working on that 20% data. And here you can see test size is 0.2 means 20% for testing, and random state 42 means every time the data should not shuffle. Okay. Now see here, convert the data into tensor. Now see, x train, x y train, x test, y test, same tensor. Why tensor? Because the machine understands the language of tensor, not this direct data frame. No, the machine understands the language of tensors only. Okay. Now create the data loader and data sets. Now see here what happens. Now train DS dataset, tensor dataset, x train, y train, and train DL data loader, that is the train DS comma batch size 16. That means the size of 16 rows, the batches are created. Okay, and then shuffle equal to true, right? So now what we are going to do here, look at this. Now model definition. Now see here, class vendor risk model. Here we have created a risk model in which sequential data, nn dot sequential, and then linear. Now see here, 4 is the column, right? 4 is the column names, column numbers, and 64 means the 64 neural networks are created. Then ReLU function is activated, that removes the negative numbers and convert it into 0 to 1. Then again linear. Here linear means 64 is the input given to it, and another time 32 networks are created, neural networks, and then again ReLU function is activated, and then finally this 32 and output is 1. Whatever the one output, either yes or no, right, it is created. Then form definition forward self dot x. Here the model equal to vendor risk model. Here this vendor risk model is kept in one variable. Now what will happen, loss and optimizer. Here we have created the loss and optimization function. Just a second, look at this. This is a standard function of creating generating the loss and optimizer function, MSE loss, mean square entropy loss, and this is a standard function, right? And learning rate is 0.001. Now training loop. Now our, as usual, we are going to train the model. Now train the model. For that, epochs 100 means 100 times we are going to repeat the loop. Okay, we are repeating the same procedure for 100 times so that the machine trains itself. Okay, so the machine trains itself. For doing this, we need to train the loop. Yes. Now see epoch in range, then YB XB. These are the two variables in train DL, training data loader, right? And then we, here is prediction, then the loss, the optimizer, the loss, the optimizer, epoch loss. All this is a complete mathematical function. And then when we run this, so look at this, the epochs is running. Now first of all you will see loss 0.104. Immediately with after 10 epoch it becomes 0.003. That means it is reducing. The loss reduces after every epoch repetition. That's the main story. Okay, after that let's let it finish. Now we are plotting the loss here. Look at this. We are not plotting the prediction, we are plotting the loss here. Look at this. MSE loss after every epoch, MSE loss reduces. Look at this, right? Now, what next? Look at this model evaluation. Torch.no grade. No grade means we are not again going backward again and again. Back propagation we are not going, right? So now we are going to evaluate our model. Okay. Now after this, what we are going to do? We are going to plot the actual risk, prediction risk, and actual versus prediction. Now see here, the actual risk actual means the blue color, predicted risk means the red color. That means whatever is actual risk, that is the same thing is in the predicted risk, right? The machine has also predicted the same risk, right? Now what we are going to do here, let me show you that also. Now predicted new is a function, right? And in this predicted new, I am going to write down this new data. Look at this, 0.7, 0.80 and 0.9. 0.9, let's take this 1, 2, 3 and 4. Now see here, 0.27 means minimum risk. Now let's see this. Financial health 70%, compliance score 80%, that means 80% it is following. Past incidents none, and delivery reliability is 0.9, that means very soon it will. Now let's take past incidents are 10. Look at this, how much risk is there? 5.40, right? Similarly, if I go with this, right, let's take one more here. 97 means financial health is 97. Look at this, 0.21. Previously it was, how much it was? 0.20, here also 0.27, right? 97. Look at this, the risk becomes very low. That means it is just like that only. When if a person is good by nature, so it is there is no risk in keeping friendship with him, right? So this is how we predict, right? So machine learning also, machine also predict the same, follows the same procedure to predict the risk, right? So in this way we predict the risk. So I recommend you to watch this video twice, thrice, because I have given you the scenario, I have explained you the scenario. Let's take a quick recap again. First of all, what we have done, we have extracted the data from the ERP. There are different criterias. There could be n number of criterias also. Here I have taken very few criteria. On the basis of that, then we have splitted the data, then we have reshaped the data, right? After that, what we have done, we have transform the data, then we train test split, we apply train test split function to separate the data, then we separated the data, right? After that, data set data loader, with the help of this we distribute the data into two parts. Vendor risk model, a function is created, and loss and optimizer also function are there, right? Then the training loop begins. After that, we plot the data, not data, plot the loss, how much loss is there, and the loss is very minimum. Then evaluation of model we do. After that, we predict the data like this, and when we see that okay, whatever the actual and whatever the predicted are both are same, then why not predict the data or assess the data on our live data? So we have created one new function, predict a new, and here we provided vendor data, that is the vendor data. Here the new vendor data is 0.97. we have given different things, right? Compliance scores, that is 97, and the financial health, that is the 97, compliance score 0.8, all these things given, and then we saw after changing the digits what happens, right? So based on that, the artificial neural network, it creates the neurals, and then it processes them, right? And here the predicted risk score is 0.21. so guys, this is how we extracted, and 0.21 means very low risk in working with this vendor. So guys, I recommend you to watch this video again, twice, thrice. It's a very important video, and if anything is not clear to you, you can put it into the comment box. I will be happy to help you there, right? And today we are concluding here only. Tomorrow we will learn something new, right? Okay guys, thank you. Thanks for watching the webinar, attending the bootcamp session. Thank you.